Hi everybody, welcome back. This is Unit 11, Lesson 4, and we're going to talk about two things, the pH scale and then naming acids and bases. So this is the same chart you have in your notes. You just may want to turn it sideways toward the left so that it kind of lines up with mine. As we talked about, the pH scale is a measure of solution acidity or basicity, however you say that. But the idea is that 7 on the pH scale here represents a neutral solution. And the lower you go, the more acidic you become. When you become more acidic, you have more hydrogen ions. So strong acids are things like hydrochloric acid, which is found in your stomach, battery acid, which is obviously in batteries, that's sulfuric acid, Coke, vinegar, Coke as in Coca-Cola, vinegar, acetic acid, that type of thing. So the closer or the lower you go, the stronger the acid. Okay, if you're up around neutral, you're a weak acid. And if you go above 7, then you're a base. The strongest bases have higher pHs. So this is the strongest base. Way up here, which is sodium hydroxide, also known as lye. Okay, and weak bases are closer to neutral. Like baking soda and other weak bases, like Tums, those are antacids, Rolaids, those types of things. Those are weak bases also. So generally, the lower you go, the more hydrogen ions you have. The higher you go, the less hydrogen ions you have. And the more hydroxide ions you have. Okay? And again, vice versa. The lower you go, the more hydrogen ions, the less hydroxide. So what you need to know and what should go in this box on the side of your paper is that as pH increases, oops, yeah, that's right. Hi. The concentration. Okay, thank you. Of hydrogen ions decreases. Okay, and vice versa. Lower pH means more hydrogen ions. Okay, kind of opposite of what you might think. Lower pH is more hydrogen ions. Now, that's great to just know the relationship qualitatively, but you also have to be able to quantitate it. So on the next page, you'll see this diagram. And what this diagram is showing is that for every 1 digit lower, you go in pH. It's 2 separate words for every, not one. And I'll just say change. For every 1 digit change in pH, the hydrogen ion concentration changes tenfold. So if you have a 2-digit change in pH, that's a 100-fold change in H+. And guess what a 3-digit change in pH would be? A 1,000-fold change in H+. Now, how does it change? It depends on if you're going up and down the scale. If you're going up the scale, it goes down tenfold. So you divide by 10 each time. We'll say hydrogen ion concentration H+ decreases tenfold. If you're going down in pH, the hydrogen ion concentration increases 10-fold for every 1-digit change in pH. So if you notice here, at pH 3, the hydrogen ion concentration is 0.001. If you go to pH 2, that's a 1-digit change, then it goes up, right? Your concentration here, it's 1,000th. Here, it's 100th. Okay? And if you go up one more, it's 0.1. And go up one more, it's 1. All right? So let's give you an example. Let's say at pH 5, the concentration of hydrogen ion is 2. It would never be that, but just pretend. Okay? It will never, ever be that. They could ask you, what is the concentration of hydrogen ions when the pH is 6? Okay? So we're going up the pH scale, right? We're going up the pH scale, so there'll be less hydrogen ions. How many less? Well, you're only going up 1 digit, so you would just take this number and divide it by 10. Move the decimal point 1 place to the left. So this would be 0.2 molar, okay? If the pH was 7, you were going up 2, it'd be 0.02, okay? What if the pH was 1? In this same situation, if the pH was 1, okay? Well, if you think of a number line here with our pH, we're going 5, 4, 3, 2, 1, 10, 100, 1,000, 10,000. You're going to move the decimal point 1, 2, 3, 4 places to the right. Okay, so at pH 1, 1, 2, 3, 4, our concentration would be 20,000 molar. Okay, that would, again, this is not probable. This will never, ever, ever happen. But just to give you an idea, that when you go down the pH scale, for every 1-digit change you go down, you multiply by 10. So if you move 2 digits, then you would multiply by 100. However, when you go up the pH scale, for every 1-digit change, you divide by 10. So if you go 2 digits, you would divide by 100. If you go 3 digits, you divide by 1,000, etc., etc. Okay? I'll show you some practice with this tomorrow. And then finally for today, you do not need to know the rules on how to name acids and bases. If they ask you for the name of an acid, you just simply need to look on Table K. They give you the names right here. These are the names. If they ask you for the name, make sure you write down the name, full first and last name. If they ask you for the formula, you can do the initials, right? Or your symbols. Okay, this is the formula. So you don't have to know the rules on how to name acids and bases. You just have to look on Table K and Table L for the acid and base names. That's it for tonight, everybody. We'll see you tomorrow. Bye-bye.
Bye.